Hi, my name is DJ Denluri, and I'm an undergraduate student for the class, and here's my assignment 2. Basic user interface, it asks you how many plies you want. Let's just do 3, which is nice and simple, nice and easy, whatever column you want to start in. Let's just do, I don't know, 6. So we have 6. The AI plays. It also gives you a nice little thing over here where it shows you how many nodes it took for the AI to make its move. And then from here, the strategy tends to be to build a wall so that to try to corral the AI to stay in one place, and then from there it's just slowly expanding that, because you don't really need to go too high unless the AI starts getting close, like see over here, because it'll start to spill over sometimes. It'll start to try to make its way into my area, and then from here I just keep building it up slowly. Oh, and I need to watch out here because it's gonna go into 5, so if I start now, I can build up 4 there, and that blocks off its route a bit. And instead of fighting for quote-unquote supremacy up top, I can just dump a lot of my coins into one section, and there we and yeah, and that's my win. From there, as for how I modeled the Simacogo, I have a vector of vectors of characters, which is the board. It's just a 9x9 board, and the characters are either a period for an empty space, a big O for a white piece, or an X for the black pieces. My nodes basically just have my board, the current ply that node is on, the ply max for the node tree, and then the black score, white score, and then the actor, which is the the uh, the 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 player at the root of the node tree, and then the opponent, which is the opponent. Um, and then board is just board is has the board has the board, and then just these scores, and that just makes it easy to print it out later on. And then for scoring, instead of going through the entire board every time, what I have is that every time a move is made, what it does is it checks the pieces in a 1 block radius around it. So it'll check the side to side pieces and the diagonal pieces, and then assign scoring respectively, just so that it's not going over the entire board when it needs to score. And that scoring algorithm is also applied over here in the player move, and I first applied it in the successor function right here. So yeah, this is the successor function, this is the player move function. The successor function, it just finds every empty column and then drops a black piece down that column until it can't go down any further. And player move does more or less the same thing, except in this case the user is giving a custom value for the column that's being that they're dropping it into, and it once again falls down until it can't fall down any further. And then for how I'm actually doing min-max, I have a get move function which calls on the get max function. The get move function's job is to mainly just set it up, so it's not so the setup all the setup isn't on the what's called on over here, just to make everything a bit easier to look at. So the get max function will get all the children for its node, and then for each of its children, it'll call the get min function on them, which in and of itself will call the get max function, and so on and so forth. The way they break is if they hit each node keeps track of what its max possible ply value is and what its current ply value is, and then if it exceeds that, it'll return itself back up the chain, until you get one node being returned to the get move function. And yeah, I think that's it. Thank you for watching.